In this video, we are going to be talking about classifying polynomials based on some of their characteristics. So before we get started, it would be good if we had a working definition of a polynomial. A polynomial, let's fill that word in here. A polynomial is a mathematical expression with constants, variables, and exponents that can be combined using subtraction, multiplication, and division. But there are a few rules we have to keep in mind when we are doing this. First of all, you cannot divide by a variable. So when it says division, this is okay. You remember a fraction bar just means division. This is 2 divided by 3, which is fine because I have 3 in the denominator. I'm not dividing by a variable. I'm dividing by a number, which is acceptable. I could also have it written like this, as a fraction. It's just that in the denominator of my fraction, I cannot have any variables. In the denominator of my fraction, I can only have regular numbers. So if I wanted to, I could rewrite this one as 5 over 15x squared minus 8 over 15x plus 11 over 15, and I could separate them out into a separate little fraction. That's why this one is acceptable. But if I had 15x, that would be a problem. All right, some things that are no, like this one. I cannot have a variable in my denominator if it's going to be a polynomial. Also this one, you may remember from when you did your exponent rules in algebra that the negative 2 power means to take the reciprocal, which would put this x in the denominator. So dividing by a number is fine, dividing by a variable is not. Okay, also a variable's exponent can only be a whole number. So look at this one. I've got an exponent of 23, an exponent of 0, and remember here I have my understood exponent of 1. All of those are whole numbers, so all of those are fine. But this one, this fraction, is not a whole number, so this one is not a polynomial. And also this one, again, I have that negative number just like I had up here. Negative numbers are not whole numbers, so therefore this one is not a polynomial either. And then the third rule is I must have a finite number of terms. So I couldn't have a plus ... at the end, implying that it goes on and on forever. A finite number of terms means it stops after a certain number. Now that could be a very large number. I could have 99 or 1,500 terms, but I just have to stop at some point. I cannot have an infinite number of terms. Okay, so now let's look at some of the ways that we classify these polynomials. The first thing we do is classify them by degree. Okay, so you may or may not remember this vocabulary word. The degree of a polynomial is its highest exponent. So I might have all sorts of numbers as coefficients. I'm not going to focus on those. I'm going to focus on the exponents, and the degree is the highest of those exponents. Regardless of what order the polynomial is written in, I'm going to focus on the highest one. So when my degree is 0, this is a constant. It would end up being a horizontal line if I were to graph it. And an example of this is this one. So you might be wondering why I have degree 0. I don't even have an exponent here at all. But remember, when you don't see an exponent, that implies that I have x to the 0 power. So this one does have an exponent of 0. All right, a degree of 1 is a linear function, and you guys saw a lot of those. Here's two different examples of linear functions. This one has x to the first. This one also has x to the first. They're just written in opposite order. Degree 2, we've spent a lot of time with these this semester. That's our quadratics. So our quadratics might be like this with only one term. It might be like this with 3 terms, but the highest exponent is a 2. And as you can see, this one is written out of order and needs to be rearranged to put into standard form. Degree 3 is a cubic function. All right, so here I wrote one with division, but remember it's okay to divide by just a regular number. Highest exponent is 3. And here I have one written in reverse order, but again, the highest exponent is 3. So both of these are examples of cubic functions. Degree 4 is quartic. Now, if you think about that, a quarter, 4 quarters make $1. a quart of milk, 4 quarts make a gallon. Quart implies 4. So a quartic function has degree 4. Its highest exponent is going to be 4, like this one. Degree 5 is quintic, like a quintet. If you have 5 people singing or playing an instrument together, that's a quintet. And here's an example of a quintic polynomial. So in my quartic polynomial here, you can see that I have put several different exponents. And in my quintic polynomial, it is much smaller. It only has 3 terms. Either one of those is fine. It doesn't matter. You focus on the highest exponent. Okay, another way that we can look at classifying polynomials is based on how many terms they have. So if we only have one term, we call this a monomial. You might remember the prefix mono, meaning one, and an example of a monomial would be 8, like we did before, but also this one that's cubic, right? It doesn't matter what the degree is. What matters is that it only has one term. If it has 2 terms, it's a binomial. Like a bicycle has 2 wheels, a binomial has 2 terms. So here's an example of a binomial that's linear. Here's an example of a binomial that's quintic, right? The degree doesn't have anything to do with the number of terms. 3 is going to be a trinomial. Just like a tricycle has 3 wheels, a trinomial has 3 terms. Here's an example of a quadratic trinomial. And then once we get to 4 or more, we just refer to that as a polynomial. All of those we lump together as polynomials. So here's an example of a cubic polynomial. Okay, let's practice with some of those. So I have several examples for us to work through. And what we're going to do first is put it into standard form. That means to put it in descending order from the highest exponent down to the smallest exponent. So 7 minus 2x there, that's written backwards. The negative 2x should be first because x to the first comes before x to the 0. All right, so now I have it written in standard form based on its degree. Okay, so look at this. What is the highest power of x? Well, the highest power is this understood 1 that you don't see right here. So the degree, this one is going to be linear because the degree is equal to 1. And then classify it based on its number of terms. Well, I see 1, 2 terms, so that's going to make this one binomial. Okay, let's look at this next one. So again, our first set of instructions are to write it in standard form. Standard form means from the highest exponent down to the lowest exponent. All right, now let's classify this one by degree. So I look across, the highest exponent, the one that I put in front, is this one, and it's a 2. So this means this one is going to be quadratic. And it's quadratic because the degree is equal to 2. All right, and then classify by the number of terms. Well, if I count, I see 1, 2, 3 terms. So that makes this one a trinomial. Tri for 3, just like tricycle has 3 wheels. Okay, let's look at number 3. So number 3, there's no rearranging. It's only got 1 term, so there's nothing to rearrange there. Degree. The only exponent, which is the highest exponent in this case, is a 5. So when the degree equals 5, I remember that this one is quintic. And then I can see again that I only have 1 term. I didn't have anything to rearrange. 1 term goes with monomial. All right, let's do a few more of those. Okay, how about this one? So when I put this in descending order, highest power of x first, I've got x to the 4th, and then x to the 2nd, and then no x, which I remember is the same thing as x to the 0. So if I classify it by its degree, that highest power that I see there is 4. And when the degree equals 4, that is quartic. All right, now let's base it on its number of terms. 1, 2, 3 terms. That makes this one a trinomial. All right, so how about that next one? All right, this next one doesn't need any rearranging. There's only one term there, so there's nothing to rearrange. The degree is going to be 3, the only exponent that I see there. And when it's 3, that is cubic. Just like something that is three-dimensional, right? A cube is a three-dimensional object, so that can help you remember that degree 3 is cubic. And I only see one term, so this one is going to be a monomial. All right, last one down there, putting it in descending order. Highest exponent down to the lowest exponent. All right, the highest exponent that I see here is 3. So just like before, this one is going to be cubic. But instead of being a monomial like number 5, I see 2 terms, which makes this one a binomial. Okay, now a vocabulary word you need to be familiar with is the leading term. And this is going to be important in Delta Math. This is also going to be important when you're looking at your in behavior. Your leading term is the one that has the highest exponent. So like in number 6 that we just did, our leading term is this one. So even when it's written backwards, even when it's not written in standard form, the leading term is still the one with the highest exponent. So negative 8x to the third would be my leading term. And sometimes Delta Math will ask you for the leading coefficient. Remember, the coefficient is the number that's in front of the variable. So in this case, my leading coefficient is negative 8. If I look back at the last ones, let's look at number 2. So the leading term. The leading term is the one with the highest exponent, no matter what order it's written in. And the highest exponent in this case is 2. So my leading term is 8x to the second. And if I am asked for the leading coefficient, it's going to be the number in front of that x to the second, which is 8. My leading coefficient in this case is 8.